Hello guys, I welcome you to the channel Nota Bene Tech on Tube, and I'm going to tell you the lecture 2, which is Introduction to Static Stability. Professor A.K. Ghost or Host Aircraft Stability and Control. It is just the continuation of the last video regarding aircraft stability and also the control. And we're going to actually just discuss what the professor has just introduced about the topic to the students. So let's see. Yes, dear students, we were discussing about static stability, and we realize and we understand when it defines static stability, we are very clear that it is to do with initial tendency of that system. If it has initial tendency to come back to the equilibrium, then the body of the system is in static stability. Okay, so this is the equilibrium, and equilibrium means all the net forces and movements are zero. And once we want to understand static stability, what we say, we disturb this, we stretch this mass and release it. And when we know that the moment I stretch it, there is a force kx proportional to the displacement. It tries to take it back to the equilibrium. It may overshoot, it may oscillate. The different issue for static stability, those things are not important. For static stability is only important that it should have initial tendency to go towards the equilibrium. That is static stability. Okay, so we understood what it defines. Okay, let's see, let's read it again. So this is the equilibrium, actually kx, and equilibrium means all the net forces and moments are zero. This is the definition of an equilibrium. That's perfectly okay. All the net forces and moments are zero. And once we want to understand static stability, what we say, we disturb this, we stretch this mass and release it, and we know that the moment I stretch it, there is a force kx proportional to the displacement. It tries to take it back to the equilibrium. It may overshoot, it may oscillate. The different issue for static stability, those things are not important for static stabilities. What is important, that it should have initial tendency to go towards the equilibrium. That is static stability. And now for this mass spring system, who is providing these static stability characteristics is through the spring. The moment I stress the spring, there is an opposing force which tries to take it back to the equilibrium. Now let us come back to the aircraft. If I say for aircraft, for time being, if I concentrate on the angular stability, that is suppose the airplane is going like this, and if there is a disturbance which tries to take the altitude up, or he have to check, it will be statically stable if it has initial tendency to come back to the same equilibrium. Okay, or to the equilibrium, that initial tendency, that means for a mass spring system, it has a spring who does all these works for. But for an aircraft, what is that agency who will ensure that the moment I am deviating from the equilibrium, there will be a restoring moment which will try to take back it to the equilibrium. Obviously there has to be the counter moment as well for just restoring it. That is, if it is going like this, if it is disturbed and its altitude has increased, then the aircraft would have a mechanism which should try to give a nose down movement to ensure that it has static stability. Obviously there must be a mechanism in which the forces, there must be an force and also the anti-force for that, or the moment or the anti-moment for that, just to keep the mechanism in equilibrium and static stability. Now the question is, for a mass spring system, there are physical systems like spring mass. A spring is giving that force or forces. However, for an aircraft, all these forces are being generated to the interaction between body and the medium, which is air in this case, right? So for example, aircraft has major component as wings, as horizontal tail, vertical tail. So whatever disturbance it experiences, if at all, in a restoring moment has to be generated, it has to come from the interaction of the horizontal tail wing fuselage from their interaction, it should generate a nose down movement. As long as it generates nose down movement for a positive disturbance, angular disturbance, angle of an attack at disturbance, we will say it has static stability. Okay, so this is the static stability in which the aircraft is in this position. And what it tells us, normally it tells us that aircraft has major component as wings, as horizontal tail, vertical tail. So whatever disturbance it experiences, if at all, in a restoring movement has to be generated, it has to become from the interaction of the horizontal tail. Okay. Okay. So this is how it will going to work. And Aerodynamics Center. Okay, let's see what the professor explains about this diagram. Okay, let us see, we all are aware of aerofoil. Let's for simplicity assume that this is symmetric aerofoil, and also we know there is a point called Aerodynamic Center. Okay, and that is the definition of aerodynamic center. It is a fictitious point, mostly low speed and moderately thickness to choid ratio aerofoil. This point is at c/4. That is, its location is c/4, and we call it quarter choid point, where we are now very clear what is a chord. And what is the technical definition of this aerodynamic center? It is that point in that aerofoil about which the pitching movement is independent of an angle of attack. Is this clear? And even if I change angle of an attack, the pitching movement about that point will be 0, right? So it is very convenient to represent all the forces and movement acting at c/4. So you will find that for aerofoil I will represent like this: CL, CD, and in general case here there will be an CM. So let's see, it's CM and it's CL, CD, and in general there will be a CM as well. Okay, now let us try to understand how such configuration can generate a restoring movement to ensure it has static stability. That is the question we are addressing. Yes, it is important to understand that in free flight, if there is any disturbance from the body, it will try to rotate about an axis passing through center of gravity. So we would like to see whatever movement is being generated, all the rotation about an axis passing through center of gravity. So what do? We say, suppose there is an aerofoil. I can now imagine that this aerofoil is a cross-sectional contour of a wing. We are very clear, we have already discussed the aerofoil in two-dimensional concept, where the foil is supposed to follow the contour. There are no lateral flows, but for a wing there will be lateral flows, but the wing contour is decided by the aerofoil. Also, we know lifting characteristics of the wing also depends upon what type of aerofoil we have chosen, right? But what we are trying to focus is on stability, mostly static stability at this point. So this is aerodynamic center, and let us say the wing, this wing I want to fly. Okay, it has enough area now. There are two positions at possible. One is, let's say, center of gravity of the wing is ahead of aerodynamic center, correct? If this is the situation, let's see what happens. Let's say that this gentleman is flying at alpha star, and that is the equilibrium, and because of some disturbance, delta alpha, the wing is going to respond. We are looking for its initial tendency. If there is a delta alpha disturbance, then at delta CL I say lift coefficient or a lift, if I multiply it with dynamic pressure, will be generated and then can be represented effectively at aerodynamic center. We have agreed on this point. I have actually taken this point. If this is true, then what this delta CL will do? This will generate a moment I say delta CM about CG, which will be nose down. Okay, if there is a positive disturbance of delta alpha, this wing has a tendency to put the wing down to make this to 0 or to come back to the alpha star. So we say it has initial tendency, and to come back to equilibrium. So aerodynamic center is behind center of gravity, then it processes static stability. Is it clear? Okay, I believe it's clear. To be more elaborate, suppose the aircraft is trimmed at alpha 2 degree. Okay, I call it alpha star, and there is a delta alpha. Okay, let's say about 0.5 degree. If they are statically stable, then what will happen? Because of delta alpha, now the angle of attack became 2 plus 0.5, and it will be 2.5 degree. But if it is statically stable, the aeroplane will have an initial tendency or produce a nose down movement, so that finally this get cancelled, or there is a tendency to cancel it, right? I will not use the word finally, because finally, once I say, I am implicitly talking about time. Okay, which static stability had nothing to do with time. There, that is dynamic stability. So correct statement will be the moment there is a changing angle of attack from 2.5, that is 2.5 degree, the airplane will generate a nose down movement to ensure that it has an initial tendency to come back to alpha star 2 degree. And this is possible for a wing alone configuration only when aerodynamic center is behind center of gravity. So you could see that the moment delta cm, which is proportional to the angle, is equivalent to the spring force kx. There also the spring force was proportional to the displacement, that was a linear displacement, and there is an angular displacement. Okay, explaining normally the center of gravity, the aerodynamic center, with the concept of alpha and delta alpha and delta star and alpha star as well. So there's how static stability is assured. You can immediately see that if there is the aerodynamic center, that if CG, which is center of gravity, is behind aerodynamic center, or I say aerodynamic center is ahead of center of gravity. Okay, that is also the condition of static stability. Then what happens? If there is a disturbance delta alpha, there will be a force here. Let's say in non-dimensional form, I call delta CL. This will give nose up moment, right? So this will actually take this way, nose up. So further this angle will increase so much, so such configuration doesn't have any initial tendency to come back to the equilibrium. So you say this is statically unstable. So what we are learning, if we want to make a wing alone configuration statically stable, I must ensure that aerodynamic center of the wing should be behind center of gravity of the wing, right? And we also realize that this production of moment, which is proportional to the angular displacement, can be thought to be analogs to the production of force because of linear displacement for a spring mass case. So I can always say this separation between aerodynamic center and center of gravity. We have some relationship or some similarity with the stiffness of the system, like for mass spring system. The spring constant K, it has some influence on the stiffness of the system. Okay, so this needs to be understood correctly before you again revisit my lecture on static stability. I will definitely going to revisit your lecture again, Professor, because it's not just a fluke to just deliver the course in a go. You have to be very, very prudent. You have to be very, very focused. Okay, now we call the aircraft as mainly, this is the horizontal, mainly those stabilizer component. Okay, the stabilizer component are the horizontal and the vertical, and lifting component, that is the lifting component. Primary lifting component is the wing, that has the primarily role to generate lift, and there are this part is the stabilizer, and its role is this. It's typically horizontal stabilizer. Its role is to give stability of the airplane, correct? So now if I draw a configuration like this, let's say CG of the airplane is here, and aerodynamic center of the wing is here, and aerodynamic center of the tail is here. So by seeing this diagram, we can simply tell, or can we not answer a question by seeing this description and neglecting the fuselage effect. So let's say fuselage effect, we are neglecting with this assumption that we are neglecting fuselage effect by seeing the location of aerodynamic center. We service CG of the aeroplane. This is CG of the airplane. Please understand that I am drawing the here this rotation. This is CG of the aeroplane. Earlier, since it was only wing drive 1, I was talking about center of gravity of the wing, but this is a whole airplane. This is the center of gravity of the airplane. Why CG of the airplane? Because airplane will rotate in free space through and about an axis which passes through CG of an aircraft, right? Once I have represented the location of aerodynamic center of wing as well as tail we saw with CG of the airplane, I can easily comment that this configuration will necessarily be statically stable. I am assuming there are no fuselage effects on neglecting fuselage effect. Why? I know because aerodynamic center of the wing is behind center of gravity of the airplane. So this will be stabilizing anyway. Aerodynamic center of the tail is behind center of gravity of the airplane, so this will be stabilizing. So this aircraft has to be statically stable. There is no issue. Now think of it as a different case. Think of a case when it says center of gravity of the airplane is behind aerodynamic center of the wing. However, aerodynamic center of the tail is behind center of gravity of the aeroplane. I can directly say this aircraft will naturally be statically stable. I am assuming that in fuselage effect is neglected. So can I directly tell, let us investigate. As far as wing is concerned, since aerodynamic center of the wing is ahead of center of gravity, it is giving destabilizing. Okay, so this is not giving stabilizing contribution because I know for stabilizing contribution aerodynamic center has to be behind center of gravity. Okay, but for tail it is of course behind for stabilizing. So whether the aircraft have adequate static stability or not, or to be more stretch, whether the aircraft will be statically stable or not will be decided by the actual contribution of wing, which is destabilizing, and the actual contribution of tail, which is stabilizing, and they will try to nullify each other. Okay, and howsoever wins, that will decide statically stable or not. If the contribution of tail is more than the contribution of wing, then I will say statically stable. Okay, for example, the storing moment, which is primary reason for static stability in this case. So the storing moment generated by the horizontal tail, if it is more than the disturbance moment or destabilizing moment generated by the wing, then only this airplane will be statically stable. The restoring moment is decided by what you could see, not only the horizontal tail, whatever lift is coming or area, but also the distance between the horizontal tail, aerodynamic center, and the CG, because it is the moment. Okay, so as soon as you will understand that when we talk about static stability, we talk about the area, we talk about the momentum, and we define so term called tail volume ratio. So this is just to warming up. This concept should be clear to you also, please understand. Okay, so this is altogether a very beautifully summarized concept of static stability, and I just want to go at the end because this is just all the diagrams and also the stuff. So I will definitely go through this this course further moving ahead. Obviously we are going to take further notes as well, and right now I have actually explained it just on the words spoken by professor. There's nothing more I cannot contribute further, but obviously some of the drawings, some of the diagrams needs to be explained in further. And if you see, if you are from that technical side, you may contribute even as a student or as an learner, or even as a professional, or even as an experienced or advanced, or as an expert. You can put in the comment section, and I'll welcome it open-heartedly. So I end up my video. Probably this is enough, so that I have taken what I have explained about the introduction to static stability. I have explained what I have explained. I've just rephrased the words in a technical term. So that is all I have. The diagrams will be taken in front because these are the aerodynamic center of gravity. The wing tail is the stabilizing factor. Okay, this is what I have actually taken it, and also so this is how it has to be explained. So more sort of a diagram which is based on center of gravity, concept of center of gravity, the stabilizing factor of the tail and also of the wings, and these are the most stabilizing factor. Okay, and control is normally dependent, and when it is in equilibrium, okay, the mechanism is in equilibrium, so the control is not off balance. So that is what the understanding I have actually extracted from this. But further down the road, there are actually concepts like the angular stability as well, and there is actually the angle of attack and the various other concepts interlinked with that. But obviously when I'm going to go or try to actually connect it with the other courses or the other courses topics, I believe that will actually cover most of the part as far as the understanding of this whole concept, because it is not just a word of mouth. A 20-minute video or 20 odd minute video is not enough to cover these specialized topics, but we are by actually connecting different topics, different courses, we may able to actually connect one concept to another. And obviously it is just a built-in a process of building the concepts yet again. But obviously we are going to connect it from one part to another, just in bits, so that if we missed something in any video, we'll able to catch up in the coming videos, obviously with the help of the Google and with the help of the courses or the lectures already been available on the links, and you can actually go through by yourself and see that what are the details. I'm going to just go through as an presenter and also the learner and also as a student further down the road, just to equip myself to how to actually further apply and develop a full-fledged equipment of the tool. But it is a very long journey ahead. I'm just taking some of the basic baby steps. So I hope that you're going to enjoy the further journey. I'll be interested in having your views. Thank you very much. Take care and have a nice day.